We've got output on the left, these two terminals, input on the right, these two terminals. No earth, so if you want to connect an earth, you'll have to possibly use that hole there to put a bolt in or something, I think, or fasten it, slacken this off, fasten it on there somehow. Well, you don't have a notch there, obviously you have all these holes, but anyway, so got live on the two inside posts next to each other and neutral on the two outside posts. So we've got input here, live and neutral. I've got output on here, live and neutral. I've put the markings on here. So output here, live, input there, live, input there, neutral. So you're going in there and the voltage coming out that you adjust, live and neutral. It's labelled alright, it covers up some of the holes, but there's probably plenty of perforation there. Just like a dress label. Right, let's get wired up and see what happens. Well, I say that this like cover here that clips down over the terminals, you can't really raise it. You can raise it up to here, and then it bangs against there, so it's a little bit hard to get in at the screw heads. You have to put the screwdriver in at a bit of an angle. Right, this is a multimeter I'm going to be using. Just a VC99, cheap multimeter, but okay. Well, at least initially I'll be using this one. I do have another one I might use as well. I don't think so. So there's a wiring I've got. I do recommend, well, I aren't an electrician, so I shouldn't recommend, but I would think that you want the earth connecting. Actually, I'm just going to wrap that wire around that hole there. So this is the multimeter on this side going out, and this is the live and the neutral in UK, 220 volts, 240 volts AC going in. Remember, this is AC presumably. I would certainly recommend you turn the knob all the way down. Presumably that's down, and you want to turn it down when it's well, you haven't hooked that on properly there. I'll have to take it apart and hook it back on. So that's down, and you want it certainly turned down. And if you're going to have it turned down before you turn it on, particularly for any inductive loads, because they can have an awful lot of inrush currents, so to speak, inductive loads and such like. Okay, I'll just wrap that round there a bit. Well, I did a loop in the wire, took the screw out and put the screw through the loop and fastened this on here. It's going to be a tighter, more definite connection for this earth wire. In UK it's yellow and green, or green and yellow, whichever way you want to say it, I think. So I've got live, which is brown, and neutral, which is blue in the UK. Okay, 220, 240 volts, give or take a bit. Right, I've set this to AC, which is like a wavy voltage, wavy line. It's auto ranging. I've turned this all the way down. I put it around like this, so because it keeps sliding off here. Well, I've got a 5 amp fuse. This is a UK plug. Sorry about the colour balance here. You put like a cartridge fuse in actually in a plug. Good plug, good design. These type of plugs, UK. See how it's insulated on the prongs. This is the earth pin. I've got live on the right when we're looking that way, and neutral on the left when we're looking that way. Okay. Right, let's get plugged in and watch out for, just a second, watch out for blue smoke, I think they call it. I'm just trying to get that display better. Line up the plug, 5, 4, 3, 2, 1. So it's saying 230 volts there. AC. 237 I should say. Well, and even of 240. So that's almost like the input voltage. Let me try turning this knob. Sorry, did that go slanty there? Well, I'll show you that again. So when I've plugged it in, straight in, 240 volts we'll call that. I'm going to turn this clockwise, slowly. Nothing. Nothing at all. I don't touch the metal even though it is earthed. I am turning that, as you see. And I feel it turning, and there's nothing at all. It's just staying on the same voltage. Input, so it's like the output is going direct to the input, not going through any electronics almost, because it's not even, is there even I mean, this is jumping about a little bit, as you see. Not the best multimeters, but okay. Well, that's fail. Certainly not doing as I wanted it to, which is, as you should be able to adjust the voltage. This is for electric motors. So I've got live going in here, neutral in there, that's right, common. Got it on AC. I apologise for lighting here, but I'll put this sort of small inductive load on here, this motor. I'll put a video down here about this, or a card or what have you, about this motor. So I've turned down the voltage. Now this can go down to 10 volts, so I put a bolt through here. There's a hole in the shaft. There's a bit of a D-shaped shaft. That's just so you can definitely see it turning. Now let's get plugged in. I did do a continuity test between the live and the fuse, and yeah, those are connected, but it's not connected to this live over here, the output. So obviously this is the input side, because, well, on this one, because some online suggests that this is the input side. Right, I'm about to plug it in now. I do not expect it to turn because it should be on 10 volts output. This is a second. 5, 4, 3, 2, 1. Sorry, I forgot to allow for the vibrations of this motor. It's not so bad when it's in something, but you can see that's turning there. And I've just turned up the, and it certainly seems to be adjusting the, my, sorry if the camera's going the wrong way here. I'm using my phone. So this vibrates off here if I don't be careful. And I've only got one hand. So how I'm going to do this, let's try this. That's a bit better. So I'm going to turn the knob, gradually turning up. Let's try gradually turn down quite slowly. See, and it stops there. Turn it back up. So we're saying that it can only work on inductive loads. See how this is like walking over with the vibrations. Be careful here because it's all open. Can I actually turn it down to slow it down? This is supposed to be high torque geared motor, but I wouldn't call it high torque to be honest with you. I can stop it by hand if I got the like bolt going through. I'm gonna try that. That's borderline. See, that's vibrating there. Have to be very careful here. So we can see what speed it's going. Now it's supposed to be doing 60 revs per minute, this motor, but that's based on the AC. So it might be 50 revs per minute in the UK because we're on 50 hertz. But it's synchronous with the frequency, so to speak. That's full on. That's fully off. I can't notice any like gradual speed increase there. Let me try something else. This is only small, what I term as a small inductive load. There's not a lot, there's only a smallish coil in there really. Okay. That does seem to be doing something, as opposed when I put the multimeter on. Right, I've wired up this other lamp here, because this is what we know as a bayonet fitting, and that's like a filament bulb in there. I think it's a low wattage. Right, again I've turned the, so as we know, I've only put this on to hold these wires in here because it slides all over the place on this desk. So this is sort of the light I am using. I'm not sure what wattage that is. Put the wattage down here, if it works at all. Right, let's get it plugged in. Standing quite far back. Trying to get in. Will it come on at all? I doubt if it'll come on because it's on the turn right down. I can't remember because it does have a switch on here. Ah, there we are. Look at that. That is extremely dim, that. I said this inductive load, but because in the way it stores the heat, it is like fading in and out a bit, I think. Don't know if you can see that. The heat will keep it lit, so to speak. Now let's try turning it up slowly. Can we get both in? Just a second, only just maybe. So I'm just turning that gradually. Yep, that's getting brighter. right there all the time, as you see. And that's probably full brightness there. Well, that's full on. Let's turn it back down. So I seem to turn it quite a lot. A good quarter turn probably. Once it starts, see, it's starting to dim there. Well, it started a little bit before that. And that's fully down. Now, going by the specifications, that suggests 10 volts, so it is working. So you need some sort of inductive load on it, I think, really. Let's do that again, just to prove it to you. Oh, well, I'll shine it, well, I'll turn this other light off. Oh yeah, it's a bit darker. Point this down, so we're getting quite a reddish yellowish colour there, and we can see it brighten up the area, and then turn it down. In fact, I don't think we really got much fine adjustment. See, I'm turning it very slightly there, and it's going, well, from bright to dark quite quick in that area there. I don't know if you can see me just turning it very slightly there. It seems to jump quite a bit, and it goes pretty bright, and then it goes full brightness, say about there. Well, not totally full brightness, it does gradually, but then it slows down how bright it's getting. Let's leave it full on for a few moments to make sure it's going to be all right, so to speak. So it is working. Inductive load on this light here. I want to see how warm this heat sink's getting. I'm not going to touch it while it's powered on. I'll just leave a few moments. I'll come back in about 10 minutes. Right, it's been a little bit over 10 minutes, probably about 12 minutes, not very long. I'm just sniffing. I can smell a bit of a smell, not smoky smell. I think it's because it's new. Like a bit, whoop, see what I mean by sliding off here. We'll get straight up. Is it warm? No, cold. What I'll do is I'll turn it right down and leave it 10 minutes. Then I'll come back. Let's get this back over here. So it's very slidey on here. Like a notch there that you could put a screw in. A couple of holes in there that will take some bolts. Don't worry, the power's off at the moment. There you are, you might see a bit of the light there. So it's set right down as far as I can turn it dim. So that might mean that the SCR, which I think this is on the heatsink here, is having to work a lot. This is bridge rectify, this square chip here, so there's no AC in, DC out. That's for the electronics, presumably some resistors. I think this is a capacitor, mains capacitor, I think. Right, I'll leave that 10 minutes set to this low setting. So you can even show the filament there. About, because it's so low. I'll put the wattage of this bulb on the video. I think it's only about 50 watts, something. It's quite a low wattage bulb. I'll just turn it up and then back down. So turn it full on. I'm going right. Sorry, I'm using my phone here. That's right down, mate. I'm going to leave it a good 10 minutes like that on its low setting, okay? See if it gets any hotter. Right, it's been over 10 minutes, just slightly over 10 minutes. Oh, another 12 minutes, we're still on low there. And touched it, you might see the light actually reflecting in the potentiometer there. It's 2 watt potentiometer. So let's unplug it. Oh no, what I'll do is I'll turn it full up. Should I turn it full brightness first? Yep. It's not working, as you see. Full brightness, dimming. Now unplug it. Make sure it's unplugged before we touch this. Oh, cool. Yep, cool. Just no heat at all, really. That's only 10 minutes, but and I wouldn't call it like a high inductive load. All we've got is that filament in the bulb there. So let this cool down and then I'll get the wattage off it. So this is the fan details, 45 watts, I think that says. So that should be a resistive inductive load or what have you. It's on the stand. The stand isn't all that strong really. It has been bent out of shape, or managed to bend it back in shape. So it's a stand fan in this case. There's a sort of motor house, and this does have a gear mechanism in so that it can oscillate sort of thing. If you can't remember if you pull this up or press this down, find out. There we are. Let's have a look. It's 3-speed, I think it is. So it's got these buttons on here. Got off, I think that's off, and then we've got medium, low, medium and high speeds, okay. Right, I've just plugged this in directly, so this isn't going through the power reduction unit. I just want to show you the speeds without any sort of power reduction. So I'll put on low first. Now you might get some strobe in here, or you might hear the oscillation on. Oh yes, we have, I think. No, that's on. Let's turn it off. No, that's on. See, you can oscillate it like this. Well, it'll oscillate. Yeah. Put it on medium. Still oscillating. I haven't pulled the thing up all the way. I'll turn it like that so it's not blowing directly at the camera. And then high. Okay, but watch this when I turn it off, especially when it's on high. So it's off and it continues spinning. So it's got some sort of inertia there. And that's to a certain extent going to be one advantage. So even if the power is pulsing, if it was pulsing, I don't think it does pulse. Don't get me wrong. It would keep on spinning, same as the filament light. If it was pulsing, the heat of the light would keep it lit, because it would pulse on so quick that I wouldn't have a chance to cool too much. Right, I'll get this wired up to the power reduction unit. Okay, I've got it wired up, and basically you're going to a certain extent have to trust me. But, be careful here because there's mains going in here. So we've got neutral on that side, live on the 2 insides, and neutral on this side. Here. Okay, that's the output. This is the input. Right, I'll put it on low speed, the fan. And this is turned right down. So yep, that's turning slower, but can you hear the humming now? I'll turn it up slowly. It is getting faster. And that's full on now on the controller. Just turn it down. Starts humming almost straight away. I'm quite surprised that turns. That's supposed to be 10 volts. Let's put it on the fast speed. Let's just jump to the fast speed on the fan. That doesn't seem to have changed it there when I put on the fast speed. Turning the controller up slowly. Turn it back down, quite slow and steady. You've seen this. There's a bit of breeze off there. Yep, it does seem to slow it down and speed it up quite smoothly there with the fan. It's hard to tell because of the inertia, as I say. Doesn't seem to take a lot of turning on the control to get going reasonably fast. But you can hear the noise when it's on low. Let's put it on medium. Put it on low speed. See, that doesn't seem to affect it when it's on the low setting. I imagine that this is putting in like more coils, this switch here. I have the switches. Let's turn it off and see, we've got the inertia. So we'd say, yeah, it does control the speed of that fan, but you get that noise. Let's put on high. Which I think is going to be very annoying after a while. We'll go in a few seconds. That's on low. I'll just finish up by turning this full on. That's on high setting on the fan. There we are. Okay. I mean, I think I've got a bit of the humming there even when it's on high, but because of the noise of the fan and the wind or whatever, the breeze coming out of the fan, because it's blowing, I don't think it overrides the noise of the motor actually. I can't say I noticed that when that humming at all when I didn't have this connected in. So even on the high speed it seems to maybe have an effect, and that could be, is it like because it is pulsing, like a bit of pulse width sort of stuff. I don't know, but as I'll say on the video, these are not Variacs. I'd say they're not much like Variacs. So there was smoke coming out of it there. It's a bit like, it does come with like a plastic covering that you peel off sort of thing when you get it. Protective covering. Okay. Right. Turn it off. Noisy thing.